Good afternoon, everyone. My name is Teni Bada, and I'm here today to present our research title is Systematic Analysis of the Emerging Synergy and Exploring the Integration of BIM and AI for the Future of Construction. The research explores two rapidly evolving technologies, building information modelling or a BIM, and artificial intelligence AI, and how they can be harnessed together for the future of construction. So, the construction sector is currently undergoing significant digital transformation among technology shaping the landscape. Among this technology shaping the landscape, BIM and AI stand at the forefront. BIM has been widely adopted for its ability to manage complex data across the building's life cycle. AI, on the other hand, brings the power of automation and intelligent decision-making. While both technologies are impactful on their own, our research explored a critical gap, what happens when BIM and AI are integrated. Our goal was to understand this synergy and how it might help to shape the future of construction practices. The history. To appreciate their convergence, it's essential to understand their individual histories. BIM evolved from 2D drafting in the 1960s to today's sophisticated platforms like Autodesk, Revit, and Navisworks. It supports 3D designs and 4D scheduling, and as well as 5D cost planning and analysis. In Ireland, the National Standards Authority, the NSAI, introduced the 2024 framework for BIM adoption, promoting the ISO 1950 compliance, open data standards, and the standardization of workflows. AI, on the other hand, emerged in the 1950s, introduced through Ireland Turning's seminal work on machine learning and John McCarthy's coining of the term artificial intelligence in 1956. Its application spans machine learning, natural language processing, and robotics. Although often viewed as recent, AI has deep roots and continues to expand in capability. Our approach was grounded in a sequential mixed method research design. This means that we combined both qualitative and quantitative research methods and conducted a logical sequence that allowed for each phase to the next. We began with a systematic literature review, or SLR, and followed that with empirical research, including 5 semi-structured interviews and a structured online questionnaire. This mixed method research allowed us to capture both the depth of experience from professionals in the field and the breadth of perspectives across the industry. The SLR served as a theoretical foundation for the study. We reviewed high-quality academic resources, drawing from platforms like Scopus, Google Scholar, Science Direct, and ResearchGate, and institutional databases such as Yates Library in ATU Sligo. The phase provided us with a detailed understanding of the historical developments of BIM and AI, their current roles in the construction sector, and the key benefits, as well as major challenges, including ethical and legal concerns. The review followed the Transfield 2003 model, which ensures rigor through 3 stages: planning the review, conducting the review, and reporting and dissemination. The model gave us structure and reliability to our synthesis. With a theoretical base in place, we moved to a qualitative data collection via semi-structured interviews. We interviewed professionals across various roles, from BIM coordinators to principal engineers. Their experience ranged from 5 to 20 years, capturing a spectrum of perspectives, from seasoned professionals with institutional knowledge to those more directly involved in day-to-day technology departments and developments. The interviews focused on 4 thematic areas: the familiarity with BIM and AI, perceived benefits, challenges encountered, and the future expectations for integration. The sessions were recorded, transcribed, and analysed using thematic coding to identify recurring insights, contradictions, and emerging patterns. In parallel, a structured online questionnaire was launched, targeting professionals across disciplines, architecture, engineering, consulting, and contracting, we received 65 valid responses and a statistical use of samples for trend identification within a niche domain like digital construction. The questionnaire included 12 close-ended and short answers aimed at uncovering the current tool usage, the level of training and exposure, organisational readiness, perceived challenges and benefits, and awareness of legal and ethical implications. The data was cleaned, anonymised, and analysed using descriptive statistical techniques and charts, as well as frequency tables to illustrate trends and applications, as well as correlations. We strictly adhered to the ethical research protocols. All participants received informed consent documents and the data was anonymised, as well as compliance with GDPR throughout the entire procedure. We also recognise the limitation of our methodology, a relatively small qualitative sample, mostly based in Ireland, and the fact that AI in construction is still emerging and some insights are speculative rather than widely validated. However, these limitations were mitigated by triangulation. We cross-checked findings from literature, interviews and surveys, and the results ensured validity and consistency. So in summary, this rigorous mixed method approach enabled us to capture a nuanced evidence-based picture of the emerging relationship between BIM and AI. It ensured that our conclusions are not only theoretically grounded, but also practically relevant, reflecting the real challenges and expectations of professionals in the field. Findings. We observed a high level of familiarity and active use of BIM. This aligns with a global and national trend, particularly in Ireland, where initiatives like the NSAI's 2024 BIM frameworks are accelerating adoption. Tools like Autodesk, Revit, Navisworks, and CAD were frequently mentioned. These platforms are valued for their reliability, centralized data handling, and the ability to foster collaborations across teams and disciplines. Interviewees noted that BIM has already become essential in coordinating across design, engineering, and construction. It reduces rework, mitigates design clashes, and shortens project delivery timelines. In contrast, AI is still in its infancy. While 87% of participants expressed willingness to use AI in daily workflows, many struggled to name AI-specific tools. Instead, AI was often referred to in general terms like automation or prediction. This indicates an important knowledge gap in the industry's awareness of AI's potential, but lacks widespread understanding of the practical applications. Nonetheless, some professionals pointed to AI's growing role in reports generating, data extraction, predictive safety analysis, and automated scheduling. This emerging presence suggests that AI could play a foundational role in transforming construction workflows if adoption barriers are addressed. Perhaps the most interesting result was the widespread recognition of the value of combining AI with BIM. The majority of respondents agreed that BIM enhances coordination, while AI adds intelligence to that coordination through forecasting, automation, and real-time data interpretation. Used together, these tools can improve design accuracy through AI clash detection, enabled predictive risk analysis, and optimized schedules, as well as resource allocation, and support decision-making across the project's lifecycle. Professionals consistently mentioned that BIM's structured environment with AI's adaptability could result in smarter, faster, and safer construction processes. So to summarize, BIM is now a digital foundation, and AI is viewed as a rising enabler. The integration of the two is not yet widespread, but it is significant. It is of significant interest, readiness, and recognition of the benefits it can bring. These findings reinforce the central premise that through our research that the synergy between BIM and AI is both emerging and essential and must be supported by structured adoption strategies. However, integration is not with its challenges. Our data revealed four main barriers: the high implication costs, the lack of in-house expertise, and the fragmentation of tools, as well as resistance to change. These barriers underscore the need for training, standardization, and leadership-driven digital transformation. We also examined the industry's perceptions and ethics. Notably, 57% of respondents agreed that BIM and AI improve project planning. An overwhelming 78% said clients should be informed when these technologies are used. However, ethical concerns stood out. Over half of our respondents expressed strong concerns around data protection, transparency, and ethical use of AI. Awareness of the EU AI Act was also low, signalling a gap between the regulatory developments and industry knowledge. Present day. Looking ahead, there is a significant industry readiness for integration. 87% of respondents express openness to the future use of AI and BIM applications. 78% showed interest in training, including future trends, generative design, cloud-based collaboration, and AI-enhanced decision-making BIM environments. But concerns persisted, with 60% fearing job displacement. Interviewees stressed the importance of ethical AI, regulatory alignment, and standardization of implementation protocols. So in the end, the main recommendations that we came to was the need for training programs, the need for updated regulatory frameworks, and the need to foster widespread industry collaboration to prevent further fragmentation as we move forward with new technologies. And to conclude, BIM is already a cornerstone of digital construction, and AI is fast emerging as its complement. Our research shows that integration is not only possible, it is necessary for data-driven efficiency and safe construction practices for the future. However, we must, with care, training, and regulatory reform, standardization, and cross-disciplinary collaboration. We hope that this study as both a snapshot of current practices and a roadmap for the future. Thank you.
Thank you.